Okay, so when we talk about bond polarity, what are we talking about? And how does that differ from molecular polarity?
Bond is just like the little bond between one from the middle element.
The one outside. So a bond is between two atoms, right?
Yeah.
So this represents a bond. But when we talk about bond polarity, we're talking about just the polarity that's associated with that. Do you remember how to calculate bond polarity?
It's that little graph where it's like 2.1 or like
Electronegativity, is that what it's called?
The electronegativity table, that's right. So you use the electronegativity table. So if I remember correctly, let's see, it's, I can't remember. I think carbon is like 2.2 or something like that. And then
0.6.
2.6.
Yeah, that's what the table I have says.
Okay. And then chlorine is 3.2.
Yeah, 3.2.
Okay. Now I was just doing that by memory, so I don't have the table right here in front of me. Okay, so then all you do is subtract the difference, right? If we subtract the difference, what is this?
1.
2.6 minus.
Oh, 6.
Yeah, that was a horrible.
I thought that was a 2. Yeah.
Good. 0.6. What is the rule? 0.6.
0.6 is 0.6 and below is non-polar. 0.6 to like 1.8 is polar, and then greater than that, it's an ion.
Okay. So this guy would be polar. What about the bond between carbon and hydrogen? I think this guy is 2.2. And this one is 2.6. So
0.08. Wait, no, 4.
okay.
Should be polar.
Is it polar?
Non-polar.
Oh, no.
Because it's less than 0.6,
Yeah.
so it's non-polar, right?
Yeah.
Okay. So this bond is going to be non-polar. Okay, so now we're going to talk about molecular polarity. Molecular polarity is talking about the whole molecule, right? So remember when we were talking about you need to know what a molecule is? This is part of the reason why you need to know what a molecule is. So a molecule represents all of these guys all together and how they're going to interact, right? So we know that this guy is polar. We know that this guy is polar. We know that this guy is polar. And we know that this guy is polar. So what's happening is that the electrons, polar basically means that the electrons are moving to one side or the other. So the one who's the most electronegative is going to have the electrons towards them more. So the electrons are moving in that direction. The electron is moving in this direction, and the electron is moving in this direction. And the electron is moving in this direction. Okay, Brenda, let's say you have 4 hot guys that are chasing you. Are you with me?
Yeah, I'm here.
Okay, so one hot guy, right? You're going to be giving your electrons to that one hot guy. You're going to give your electrons to the other hot guy, and you're going to give the electrons to the other hot guy, and you're going to give the one to the other hot guy. Now, all of these hot guys are the same, right? They're all hot. They all have money. They all treat you good, right? So you're
All
cool
right.
with giving your electrons to them, right?
Yeah.
Okay. So are you going to favor any of them more so than the other?
No.
No, right? Because they're all treating you the same. They all treat you good. They all, take care of you. They pay for everything like that, So in that case, are you going to have a preference towards any one of them?
No.
No. So then in that case, it's going to be non-polar. And it's also going to be symmetrical because you're going to be giving love into all 4 of them, right? Loving them all for the same. Okay? Piece of cake, right? So in this case, symmetrical and non-polar. Okay, so now in this situation here, we have two guys here. So these guys, these are bums, right? So they're not giving you any love, and they don't take care of you. Every time that you go out, you have to pay for everything, right? They want to take all your money, right? Now, but you have your two hot guys. So two hot guys and two bums, right? Who are you going to want to spend time with?
Not the bums.
Not the bums, right? So
Yeah.
you're going to divvy your time up between these two hot guys, right? Fuck the bums, right? They're not worth your time. So the majority of your time is going to be spent between those two hot guys. None of your time is going to be, or minimal of your time will be dealing with those bums, right? So in this case, is this a polar molecule or a non-polar molecule? Is it favoring one side or another?
There's favoritism. So.
There's favoritism, right? So in this case, it's polar, right? It's a polar molecule. And it's asymmetrical because the hot guys are getting the time where the bums don't, right? So that would be asymmetrical. Okay. Does that help clarify it?
Yeah, that helped a lot.
Okay, so we've talked about alkenes, alkanes, and alkynes. Did we talk about if they're side chains? Have we talked about side chains?
Yeah.
Yeah.
Okay, so I'm going to introduce you to another one. So I always like starting off with the alcohols, although I shouldn't. Okay, alcohols. Let me give you the generic structure for an alcohol, and then I'll show you an example of an alcohol. So the generic structure of an alcohol is R represents the hydrocarbon, OH. So again, R represent basically any hydrocarbon that you have, and if you have an OH attached to it, it's an alcohol. So this here represents the bond between oxygen and that first carbon. So this is going to be my first carbon. So the way that we name alcohols is we always want to count our carbons. 1, 2, 3. Let me use a different color so you don't think it's a side chain.
I actually thought it was a side chain for a second.
1, 2, 3, 4, 5, 6. Okay, so it's a 6 carbon. So what do we call carbons with 6 carbons?
Hex.
Okay, so we call it hex. And since they're all single bonds,
Hexane.
hexane, and then we put all. It gets alcohol's last name, all. And we'd say, just for purposes that we know where the OH is located, we call it 1. Get it into it. 1 hexanol. Okay.
Mm-hmm.
Okay, what about this guy? What would we call this guy? So what is the first thing that we want to do?
Count the
Longest,
The longest
find the
chain.
longest chain.
Find the longest chain. Okay, so again, here you could go 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could go, this could be 1, 2, 3, 4, or we go 1, 2, 3, 4, 5, 6. So what is the longest chain?
9.
9. Okay, so we're gonna.
So you
And-
don't count where the chain is by OH?
Nope.
Okay.
So you want just your the longest possible carbon chain you can get.
Okay.
So that's 1, or we could start from here. But which one is going to give us the shortest distance to our
Left to right.
function?
From where you just started.
Okay. Okay, so this guy is going to be called
Non-name.
and then it gets the alcohol's last name, but we have to tell where the alcohol is at. Where is it located at?
4.
4.
Or
So it'll be 4 nonanol. Nonanol. No.
So the
Nonanol.
one in the 4 is just the location of the alcohol?
That's right. Yeah. So the numbers tell me the location where the alcohol is at, the OH is at. Okay. Okay.
is there a reason why the E is not for why you took the E out for the what is it? Sorry, hold on, let me find it. For alkane, you know how it has a E in the end, and I know this is a single bond.
Yep.
Wouldn't it be spelled NONANE?
But that's because it's a single bond, right?
Yeah.
And it's only a single bond. There's no alcohol or anything like that. So you drop the E. That E is going to be droppable. So if you're
Okay.
talking about another functional group, you drop that E.
Oh, okay, gotcha. If
Okay.
I gotcha, but since it's alcohol, you take the last 2 letters of alcohol and kind of substitute it in there.
Yep. I'm going to stop sharing for a second because I need to get some information.
Thank
I
you.
have a few people that are struggling to get in, so I'm giving them a long way. Did you guys have to enter password to get in?
No.
No.
Not
No.
Dr. Henry, for this one, we're not done yet, right? Because we still have to name the the branch.
What branch? Let me share.
So wouldn't
Which one?
it's 4 nonanol, but wouldn't we write like 1 methyl?
Hold on. Let me see what you're talking about, and then I'll tell you. Where's the methyl?
Wouldn't it be the side line?
What side one?
The
Circle it on my screen, what you're talking about. That's not a methyl, right? That's your OH. So this here represents the bond between the carbon and the OH. Just like this represents the bond between the carbon and the OH. So what it looks like is this. You have C, you have O, and you have an H bonded. That's all that is. And so that's this this carbon here is part of that main chain. So your quote side chain here is a functional group that has priority over the hexanes. And that's what we're going to build on right now. Yeah, technology is a base sometimes. Okay, so we had alkanes has the lowest priority. Who's second?
Alkyne.
Alkyne. But who's top dog so far?
Okay.
Okay, and now alcohols are above them. So because alcohol has priority, even though it's a side chain, it's considered to be a functional. It's considered to be the main name. And all you have to do is tell me where that alcohol is, or the OH is. You got that, Raul?
Yeah, I understand now.
Okay. Okay, so let's give it another shot here.
Wait, you said the alcohol has more importance than the alkene?
Yeah, so this is the low so far. We have our lowest.
Mm-hmm.
It goes up. That's in terms of priority. So alcohol is more important than the alkane because one thing you know it is because it has its last name at the end. We don't have an E there.
Is there any other substance that's like that?
What do you mean? Another functional group, you mean?
Yeah.
Oh, we
sorry.
got plenty. We got a few to go through.
Okay, so so alcohol is a functional group.
Yeah, these are called functional groups.
Okay, I was trying to think of what is it called. Thank you.
I will often say families
Okay.
because that's how I was taught it. Families, and it's a lot easier to recognize a family than a functional group. They all belong to this family.
Mm-hmm.
You know, they all have the same last name. They're family, right?
Mm-hmm.
Okay. Okay, so what would this guy be called?
Propanol?
Trinol?
Somebody said,
Butanol?
do the count. How many carbons do we have?
3?
3.
2, 3. So if it's 3 carbon,
Pro.
prop.
Yeah. Propanol.
And then where is it located at?
Second.
2 propanol?
So 2-propanol. You guys probably know this as exactly. So isopropanol, it's called iso because you have the alcohols in the middle and both sides are the same. Iso meaning the same. Okay, pretty good. Okay, so let's make it a little more challenging. You know, this is too easy. Oh, we'll do one more before. Whose birthday it is this weekend?
Fine.
Okay. So, although you're not 21,
Nope.
what is this guy called? Now, this is drinking alcohol. This is your vodka.
Methanol?
Methanol?
How many carbons do we have?
2.
2.
1, 2, right? So it's
Ethanol.
ethanol. Yep.
Oh.
Now the person that said methanol, you don't want to be drinking methanol. Methanol is wood alcohol, and it causes you to go blind and get hairy palms.
What's it called? Methanol?
So this guy is called ethanol. Methanol looks like this.
For
Well, if you
ethanol,
want-
would that be 1 dash ethanol?
Well, no. So this, because there's only 2 carbons, right? It's 1 and 2. It's just called ethanol.
Okay. Jesus, fuck. What if the OH was hanging out on the 2, on the second carbon?
Then that second carbon would be a 1. There's only 2 sides, right? So it's either here,
Oh, duh.
yeah.
Okay. I get
and
it.
it's
Thank you.
dictated by the OH. So it's always going to be ethanol.
Okay, thank
What
you.
made you count from? What made you put like on the bottom of it of the? You know, where you have 1 right by ethanol. What
Why
made
did
you
I put it?
put there and not 2 and then 1? You know what I'm saying?
It always starts your if you're a terminal,
Uh-huh.
if you're a terminal functional group, you always want to start with the functional group that has the most priority. So that's going to be where you're going to start at. You understand?
Okay. So because alcohol is priority right now, that's why 1's closest to it.
That's right.
Okay.
And if somebody's above alcohol has priority, then it changes.
You understand? Okay. Yeah, that just confused me with it being a shorter one.
Yeah. And that's part of the reason I put it up there, because I want to keep you on your toes. Okay, so let's draw another one. And then we'll move on to our next functional group. Now, since we're talking about these functional groups, we talked about alkanes, alkenes, alkynes, alkenes, and alcohols. What is the best way for us to memorize this stuff, to kind of get it to stick? I'll let you guys think about that for a second.
Acrostics.
Start with L.
You said start with L.
AL, yeah.
Is that how you're going to memorize it? So how do I know best way I can determine a double bond? That guy is going to be what? Up here. Do you guys see it? That's going to be an alkene. And you knew that because of why?
So I would try to memorize it by the letters after the K. The first letter on the alphabet for the single bond's a A, and then on the double bond, the second letter.
Are there tools that we can use to help us memorize it? I guess that's what I'm asking.
Make a song.
You can make a song? Yeah, you can make a song. That's good. I'll have to use that one for next semester. How do you memorize your, any other way? How about flashcards? Will flashcards help?
Yeah.
Yeah.
Okay, so let's look at this guy down here. So what am I going to do first?
Find the
longest chain.
And the longest chain.
Find the longest chain. Okay,
There's 2 and they're both 7.
so we have options, right? So we could go here, 1, 2, 3, 4, 5, 6, 7.
Wouldn't you want to start the other way since it's
That is correct.
OH?
See, keeping me on my toes. Or this could be 6 or 7. So we have choices, right? But they're the same, so it doesn't matter. Okay. So what would this guy be called?
Heptanol.
Ethanol.
2-heptanol.
Okay, so it'd be 2. Raul, are we done? Excuse me.
What was that?
I said, are we done?
I
Yeah,
don't
blame
think
my-
so.
It's not all over my laptop.
No.
Oh, well, there's the extra strands.
The
Chain.
methyl.
That's right. We have our side chain. So what is that side chain called?
Meth.
5.
Would it be an
5-ethyl.
5-ethanol?
5-ethyl. That's right. Ethyl. We don't put an all at the end. We just put a 5-ethyl because it's a side chain. 5-ethyl 2-heptanol. You feel it?
Where the 5-ethyl came from.
Because that's a 5. I know it doesn't look like it. It's a retarded looking 5.
Oh.
So this is where my question comes in now. If we would have started the other way, it would have been 3-ethyl, right? Because it's 1, 2, 3. 3-ethyl and then 6-heptanol.
But why wouldn't we start the other way?
This is
No,
alcohol.
I'm just asking.
Yeah.
But there's
So-
no reason to, because alcohol is on the right. But I'm just saying
That's correct.
hypothetically, because okay.
Yeah. So if you had your alcohol over here, then it would be yes. So, but you want to pay attention to where things are located, right? You want the shortest distance to the guy at the highest functional group, right? That's ultimately the goal. Or sometimes you can't help. You may come across another structure before it, then they kind of went out.
I got a question on how to order them. How do you know which one goes first when you name them?
So the side chains always go before the main guy, right? So this is your main chain. This is considered to be your main chain, including that, the alcohol, because the alcohol has functional group, has priority. Now,
Okay.
the side chain then go in front, and then they do it by alphabetical order. Okay, so if let's say we had that there. So if I had that on the side, another additional one, so then it would be 5-ethyl six methyl. Oops, if I could spell methyl. Okay.
Okay, yeah, I got it.
Why does the 6 come before the 5?
Why does the 6 come before the 5?
Yeah, so why is 6-methyl before 5-ethyl and not? It's not.
Okay, because we base it upon what? The ones up here, we base it upon alphabetical order. E is before M, is it not? So we put this one first and then that one. So the order that we put things in will be alphabetical order after, in front of them.
Dr. Henry?
Yep.
I have a counselor's appointment right now, so I'm gonna have to leave.
Okay. It's going to be recorded. We'll try to get it up before the end of the weekend.
Okay.
Okay. So just take a look at what you missed. Have a good day.
Okay, thank you.
Okay. Let's see. You guys ready for the next functional group?
Yeah.
I think this one is an easier one. Our next functional groups are amines.
The what? I'm sorry.
Amine,
Okay.
like You know ammonia?
Yeah.
Amine. What is the characteristic of ammonia? What is the chemical compound for ammonia?
Isn't it like
Oh no.
I forgot.
No idea.
Well, you want to know that because it was on your exam. And it will be on this next exam too. A couple of times. Especially now. Chemical formula for ammonia.
Isn't it like NO3 minus or oh NH, yeah.
So this is ammonia. Amine is R prime and R double prime just represents hydrocarbons, or they could be hydrogens. Okay, so I'm going to show you some examples, and then we'll name them. No yawning.
I'm tired.
Okay, so what is this functional group here? Or what is this side chain? How many carbons?
2.
2? One. One carbon, right? Because this represents the bond for the nitrogen, that carbon. Okay, so if it's one carbon, what is it called?
Meth.
Okay. If it's a side chain, it's called?
Methyl.
Okay. So it's methyl amine. Okay. Let's see. Let's change this.
You don't space the methyl.
No, with the amines, you just put it together. You group it together. Okay, so this guy. What do you think it's going to be? Its name. What is this side chain?
Ethylamine.
So that side chain is ethyl. What is about this side chain?
Methyl.
So this guy would be called ethyl methyl amine.
Is it methylethanamine?
Ethyl methylamine, yes.
Okay.
What about this guy?
Ethyl, I mean.
Wouldn't it be
Ooh, what about isoethyl?
Dimethylethamine?
There we go. It's called diethylamine. Because there's two of them. This is one, that's the second one. Okay, what about this guy?
Is iso for 3?
No. ISO, when we talked about isopropanol,
Yeah, that's where I'm confused.
That means that these guys are all the same on both sides of that. So that is the special name that we give it, a common name that we give it. Kind of like we call ammonia, ammonia, right?
Oh, a common
And we call
name.
water, water.
Okay, I'll write it down so I don't confuse myself. Thank you.
Okay, so let me do.
Where'd you get is the di for diethylamine, is the di because there's two ethyls?
That's right.
That's right. Okay. And then would 3 be what, tri? Does it go like that?
That's right. 3 would be tri. And then 4 would be tetra. And 5 would be penta. So you could have pental, penta, something, right? 5, something 5, yeah.
Okay, thank you.
Okay, what about this guy here?
Would it be ethyl propyl butylamine?
So which one is alphabetically? Which one would come first? Butyl.
Butyl.
Okay. Then, so that's 1, 2, 3, 4. That's your butyl. And who would come next?
Ethyl.
Ethyl. And then our last one would be propyl amine. Okay.
I got a question.
Mm-hmm.
So you know how like when you get the methyl and the ethanol and all those, depending on the numbers, how do you get the YL? Like, where did you get the YL ending for them?
Because they're side chains.
Side chain. Okay.
Okay.
YL is always side chains.
Aw, you don't have to say thank you to me. You're welcome. Okay, are you guys ready to go?
Okay. So, are you ready for the next one? Are you feeling comfortable with the amines?
Yes.
We'll go do one more.
One more? Sure.
It would be triethylamine.
Piece of cake?
So just to confirm, anytime there's a hydrogen attached, that just means it's an amine group or family, and we don't have to name it at all.
If there's a hydrogen attached, you don't have to worry about it. It's taken up with that amine part, right?
Okay, okay.
So this one is only a methyl. So you only want to put the names of the carbon structures added on there. So if we had this, well, we know that this is ammonia, right? But it all stems from there. So amine comes from that ammon. And so let me kind of explain this as well. So this guy would be called a primary amine.
The N.
Yeah, because there's only one thing attached. Tertiary, primary, binary, amine, and then this will be a tertiary amine. Meaning three things are attached to it.
Okay,
Okay?
got it.
I'm sorry, not tertiary, not binary. Secondary would be the term actually.
Primary, secondary, tertiary. Thank you.
Okay, questions? Let me move on to the next one.
Dr. Henry,
Yep.
quick question for the last one where it's butyl ethyl propylamine.
Yep.
The reason we start with prop is because prop is the smallest chain, right? So we start with prop. That's why it's propylamine.
Nope.
No.
Look at it. Yeah, B, E, or P. Is there a trend that's going on there?
Alphabetical order.
Alphabetical order.
Oh no. I mean like for the strand. So like one of them has 1, 2, 3, 4 carbons. The other one has 1, 2, 3, and then one of them just has 2. So that's why we put propylamine because that one's the one that only has 2. Oh wait.
No, we put propylamine because of alphabetical order.
Okay.
Because 1, 2, 3, 4, right? So 4 is but. 4 would have more carbons. Prop has 3. 1, 2, 3. And F has 2. So it's in this order. We put propylamine because P is higher in the alphabet than E or B.
You mean lower, right? It goes from closest to A to farthest from A, right?
Yes, yes. So it's in alphabetical order. Yes. B is close to A, right? Then E, then, so your last one is going to be the one that has the order's name. So let's say we had, let's do it. Let's do this. 1, 2, 3. 1, 2, 3, 4, 5. So what would that be?
Pentyl.
Bent.
It'd be pentyl, right? Oops. Okay. So then pentyl would go in the middle because it's PE versus PR. Let's say we had this. Trying to think, I can't think of anything. And then we'll do this. 1, 2, 3, 4, 5, 6, 7, 8. And then we'll do
1, 2, it's butyl.
okay. Okay, how many carbons? One, 2, 3, 4, 5, 6. 1, 2.
8.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so what would this guy's name be?
Ethel will go first.
Ethel will go first. And then what, Raul?
It'd be 6 would be it'd be hep.
Hex? Hexel? What was that? So it'll be ethyl hexyl octyl amine. E, H, and O. Are you getting it?
Yeah.
Okay, our next one ethers, actually. Now, ethers are, they're lower on the totem pole, but they're kind of weird. So so yeah, the old way that we used to name them. So ethers are just basically oxygens with 2 carbon chains attached to each side. Similar to the amines. You saw how we handled the amines already. So with ethers, we call this guy, how many carbons do we have on each side?
Is ether the family name?
Ether is the family name, ether. So this guy right here, what would this guy be called?
E.
Or what do you think it is?
Methyl, dimethyl.
So this guy would be called dimethyl ether. What is this guy called?
Ethyl.
Prop.
1, 2, 3, 4.
Methyl prop.
2, 3.
Ether.
There you go. So it'll be ethyl, propyl, ether. Okay, last one.
Ethyl. Wait. Ethyl pentyl ether.
Butyl, pentyl,
Ether.
ether. Piece of cake?
Yeah.
You're like, yeah, I can remember that one, right? Okay, so our next family, these guys are called, and they're at the very bottom of the totem pole. Oops. Okay, what are halides or halogens?
Aren't they just before the noble gases?
They're just before the noble gases, that's right. So if we have so this guy would be called longest carbon chain, 1, 2, 3, 4. So this guy would be called chloro.
The slippers are in my house. It's on the floor.
4 carbons. What do we call 4 carbons? And all single bonds?
Youth.
Butte.
And if it's single bond, what would it be? Ane, ene, or I?
Alkane.
Oh, Ain.
Ane.
Okay. So this guy would be called
Okay, so you
2-chlorobutane. Because the alkanes have priority over the halides.
Oh.
What about
So-
this guy?
Chloro is for the halide?
Yep. You just put an O instead of saying chlorine, Cl.
Uh-huh.
You put chloro instead of chlorine, chloro.
Okay.
So there's a chlorine atom.
Yeah, there's a chlorine atom up top.
Oh, but this would go for any of the halogens, you mean, right?
That is correct.
Oh, okay. I thought you meant it would be chloral for each one.
No. Each one is different, right? If it's I, you're not going to call it chloro, right? What are you going to call it?
Something with iodine.
Iodine? Something.
Okay, so let's try it. So carbon
Io-
chain.
io-
What is our carbon chain? Let's count it.
6.
So that last part is going to be, if it's 6 carbons, single chained,
Hexane.
okay? So where is the iodine located at?
2.
2.
So it's 2 and iodine. So what am I going to do? Chlorine, what did I do?
Chlor.
IO.
Iodo.
Would be IO.
Iodo. So you add
Iodo.
in.
Cool.
It's hard. Yes.
And then what about the bromine?
Bromo.
Bromo.
Oh,
Bromine.
So 3 bromo, 2 iodohexane. Okay. What about this guy? We'll do. Oops.
Hmm.
Are there any more functional groups?
Yes, there's a lot of them. I'm only going to get some of them.
There's 6.
Okay. So then we'd call that.
Hexane.
Okay. So which way should we count from? This side or this side?
The
The right
Right
side.
side.
Right.
1, 2, 3, 4, 5.
Okay. So it's hexane. Okay, so then what else?
Since there's 2 fluorines, do
Di.
you use bi?
Di.
Di. Okay, that's right.
Difluoro.
Difluoro.
Ane.
So fluoro. Fluoro. And then you have to tell me where they're at. Where are they located?
4.
4. So it'll be 4, comma 4, difluoro. And then what?
Oh, 3.
3.
2, 3 methyl.
2,3-methyl. Dimethyl, right?
Wait, so we list out 4, 4 because there's 2 fluorines?
We put 4, comma 4 because it tells me where the fluorines are at.
Oh, so, okay.
Yep. They're at the 4th carbon. They're both located there.
Why did we count from the right and not the left?
Because if I counted from the left, what would that give me? That'll be 1, 2, 3. So my closest structure would be on the 3rd carbon, where if I count from the right, it'll be 1, 2. My closest structure will be at the 2 carbon. We want the lowest number.
Okay.
To the ethyl.
What is that?
It's the lowest number to the ethyl.
To the methyl.
Oh, that's right. Yeah, that's what I meant. That's how this one works.
Yep.
Okay.
Yeah, because if you look at it, A and E is, those single bonds are a priority over halides. Halides are like bottom of the food chain. Okay, so this is the order of priority so far. We got a couple more. We have what, 3 more? 3. Let's see, make sure I'm not lying here. Well, it's 3 more that we're going to talk about today. So how are you feeling so far?
Good.
Pretty good.
Yeah. Which would have been the easiest so far?
The ether.
The ether?
Yeah.
Okay. So Zoom is gonna try to update again. So I have to postpone it because it keeps crashing. Okay, let me clear.
I have a question.
Yep.
Where is 2,3-dimethyl?
Here's 2, here's 3.
It's two of the same ones.
So there's two of them, 1, 2. So that means you have to use dimethyl. You have to tell me one is located at the 2 position, one is located at the 3 position. Do you see that?
Yeah.
Okay, so the next group that we're going to talk about, actually, we're going to do 3 at once so you can kind of see the distinction between all 3. So we have so these guys are aldehydes. So I should say that guy's an aldehyde. This guy is a carboxylic acid. And then this guy is ketones. Let me put these guys on my list.
Oh, these are the next 3?
Yep.
Okay.
Okay. Carboxylic acids are at the top of the food chain, so they have priority over everything. Okay, so aldehydes, let me show you what the structure really looks like. So you have a carbon double bonded to an oxygen. In the case of the aldehyde, there's an H, and then your hydrocarbon. Okay. This guy has a carbon double bonded to an oxygen. And then it has an hydroxyl group, hydroxy, so OH, and your hydrocarbon. This guy. Okay. So do you see the difference between all 3?
Yeah.
Yes.
Okay. But they all have this in common, that OH. And that's what people always end up messing up. All right. Okay, so let me give you some examples. We'll start off with the aldehyde. And then I'll tell you how to name it. And we put the H to let us know that it's an aldehyde. Help remind us. Okay, so what would this guy, how many, longest carbon chain? Starting with that carbon right there. What would be the longest carbon chain?
7.
1, 2, 3, 4, 5, 6. Right? Because this is your first carbon.
Yeah.
Okay. So then what is the prefix for a 6 carbon? So this guy would be called hexanol. So it gets the Al from aldehyde. Okay. And try another.
Yeah.
Let's see. Okay, what about this guy?
Wait, no. 9. Nano.
Okay. Nano. Okay, anything else that we need to include?
6 5,5-dimethyl.
Is it, what about here? Is that another methyl group?
So it's 5,5,4 trimethyl.
So it'll be 4, 5, 5 trimethyl. Okay.
So on for that one, nonanol, right? The nan is from alkane, right?
That's right, because they're all single bonds. Yeah.
But isn't it a double bond where the O is for oxygen?
Yeah. So the main chain, except for the bond between the O and the, is all single bonds. So then we always use that since they're single bonds. If we had a double bond over here, what was that?
That's why we don't count the chain of going to O?
That's right.
It's not part of it?
Yeah, it's like it's a functional group, but you don't count that as a, even though it's a double bond, you don't count that as your main chain because that's carbon there and that's a hydrogen there. But this is your first carbon, right? And then all of the carbons beyond here are all single bonds. So that's why we're going to be using the AN. If we had a double bond in here, we would use an EN to let us know that there's a double bond in there.
Okay, thanks.
Okay. Okay, so we'll do the ketone next. So the ketone is pretty easy. So with the ketone, all you do is count the carbon chain, your longest carbon chain. That's 1, that's 2, that's 3,
5.
4, 5. Okay, so we have a 5 carbon. What are we going to call that?
2-pentanone. Would it be 2? Or
2-pentanone. Good job. What about this guy?
Decanone.
1, 2, 3,
3 decanone.
8, 9, 10. Okay, so it would be 3 decanone. Piece of cake?
Yeah. Finally understand something.
So the number that goes in front is where the O is, right? With the double bond of O is?
That's right.
Okay.
Yep. And you don't worry about here with that because these are terminal. They're at the end. Okay, here, first thing that we're always going to do, what is the first thing that we're going to do?
The main chain.
Yeah.
Okay, so this case, this guy is going to be 1, 2, 3. So there's 3 carbons. What do we call a 3-carbon chain?
Prop.
Prop. And then here we put AN because they're all single chains or single bonds.
Mm-hmm.
And then we put iodic acid. So proponic acid.
Can we do another one?
Sure. Let me move some of this stuff around. Gives a little more room. No yawning. Hey. I'm going to start thinking you think my class is boring.
Sorry.
Okay, let's see. Let's do.
Where did you get the IOC from? For in
That-
Proponia. Sorry, I went to the bathroom really quick. I missed it.
I typed that wrong. Thank you for correcting me.
Oh, okay. Well, it's like normally it makes sense, but I can't figure it out. Oh, just proponic. I see.
I see, yep. Proponic.
Propanoic.
And I said it wrong.
Propanoic. Where's that O from?
The O helps us remember that there's an OH, right? Here.
Oh, I see. Okay. Thank you. People, give me one too. Why are you hugging them all? Give me one, please.
Okay, this guy.
One,
My
two,
goodness.
3, 4, 5, 6.
I was gone for 2 minutes.
6. 6, 6, 6, 6.
7.
Somebody said 6.
Isn't it 7?
Oops. Let's see, 4. I can count. 5, 6, 7.
So
That would be the longest carbon chain, right?
So it'd be heptanoid.
Denoic.
Then it would have a
5
5.
methyl.
That's right. So it's 5 methyl heptanoic acid.
aldehydes and carboxylic acids are always going to be at the end, right? So
That's right. They're terminal. Yep. Terminal functional groups.
What does that mean, terminal?
At the end.
Oh.
Like terminus, the end, terminal. Okay. How you feeling so far?
Good.
Good. So we're going to do a test here. You guys ready for your test?
Yeah.
No.
No. Not yet.
We'll put you guys in rooms and see if you guys can work through it. I'll pull it up on the screen here in a second. Okay, are you guys ready?
Which ones are we working on?
Oh, you're going to be working on them all. So you're going to identify. I'm going to do some identification here. Hold on. Let me find my window here. There we go. Okay, I didn't yawn. That wasn't me. Can you guys see my screen?
Yeah.
Yeah.
Okay, so you're going to identify all of these guys, and you're going to tell me the family which they would belong to based upon the highest functional group, the highest priority functional group. Okay?
Oh my goodness.
Now, there are more functional groups, but these are the ones that I want you to work with because you're going to see some of the, particularly like the alcohols and maybe a ketone here. And there's one other thing I forgot. Okay, one more thing. What are proteins made up of? Anybody know?
Isn't it a meat? No.
Amino acids.
Amino acids.
Yeah.
So this is the generic structure for amino acids. So there are, do you guys know how many amino acids there are in the most common protein? How many different amino acids, I should ask?
3 or 4.
4, isn't it?
Nope, not 3 or 4. How many different amino acids are in the human body?
No idea.
Or in a protein? Not 3 or 4, much higher. Or not much higher, but higher.
About 20?
20, exactly, 20 different amino acids. Okay, so, and we said this is an amino acid. What is this group called? If you just saw this and a carbon attached to it, what would you call it? Which family would it belong to?
Hydrid.
It has an N in it. Come on, we just talked about it.
Amine?
Amine. Okay, that's right, amine. Okay, and if we have this guy, what group is this guy? Which functional group is that guy?
That'd be a carboxylic acid.
Very good. Okay, so you get your term amino acids because you have both present. Your amine, so amino, and your acid. Okay, ready?
Yeah.
Okay, I'm gonna put you in groups. Okay, how did it go?
Oh, Whoopi, yes.
Good.
It was okay.
It was okay. Sound like you're tired.
I am tired.
Okay, so let's see. Okay, here you go. So we'll do this. Let's see, break up rooms. Okay, room 1. That was Brenda's room, Sandra's room. You guys do A. Room 2, you guys do B. Room 3, you guys do C. I'm sorry, let me tell you who room 2 is.
Yeah.
Room 2 is that's Kevin, that's Osmond, that's Stacy. Room 3, that's Aaron and Ivan and Jennifer. Room 4, you guys do D, that's Hector and Xavier. Room 5, that's Angie and Jeff and Jennifer. And you guys are going to do E. And then room 1 will do F. Room 2 will do G. And room 3 will do H. And room 4 will do I. Actually, we'll let room 5 do I. Okay, write it on my board.
Dr. Henry, what group are we? What group am I in? Like, it cut out when you were saying the groups.
you are in, Raul.
Jackson,
You're in group 3.
here's
You're
your
doing
phone.
C,
Thank you.
and you're doing
Oh, sorry, babe.
H.
Okay.
Wait, Dr. Henry, I have a question.
Yep.
When like looking at the side chains in order, we still do alphabetical order or by the least side chains?
You're going to do by alphabetical order.
Okay.
In the old days, when I started, they used to do it by priority in terms of who was the longest, who was the shortest, so, or functional group. But they've changed it. Now it's alphabetical order.
Hi, 1 second.
And then room 2 is doing G too, right?
What was that?
Room 2 is doing G too.
Yep.
I had a question for A.
Okay.
So there's since there's I think there's 3 what are they called, methyls? Is that what they're called?
That's right.
Would you count them all 3 in one, so it would be trimethyl? Like
That
it
is
would be.
correct.
Okay, so then it would be 2, 2, 4 trimethyl.
Yep.
Okay, yeah, because we were kind of debating about that in my group.
Wait, can you explain that again? Or can you fix that?
Yeah, I'm confused now. Okay.
Oh, because
So 2, 2, 1, 2, 3, 4, 4. Because this is not an ether, right? You guys know that this is not an ether. That's 2
No.
independent chains. They're not connected together, right? That are coming off of that carbon. It looks like this. See? And then you have chains coming off of that. Okay, so 2 independent chains. So the correct answer would be 2, 2.
Trimethyl.
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 I thought it was the same. It was together. That's why. Okay.
And then is it 1, 2, 3, 4, 5, 5 ethyl. Okay.
Okay.
I'm just going to change that color so we know we're not talking. Oops. Wow. Won't let me do independent colors there.
And you said group 1 also had to do F, right?
Yep. Oops. Okay, so let's fix this here. You've already taken care of the ene at the end of the thing, so you don't have to do it there. So it'll be octene, okay? And then you said, so that's 1, 2, 3, 4. Okay?
For D, you know how there's two ways to write it?
Yeah.
Could the other one be 5-ethyl, 3,4-methyl, non 1-ene?
Let's see.
Oh,
So
there's 4. 1, 2, 3.
No, 8 would be the longest. 1, 2, 3, 4, 5,
everything.
6, 7, 8. If you went 1, 2,
Right, there's 8. Yeah.
4,
There's a
5,
line there
6.
because of the
1, 2, 3, 4, 5, 6, 7. Yeah, 8 is the longest, so that would be the only way.
For D, you have to put a 1 before octene because that's where the double bond is, right?
That's right. Yeah, the only time that you put the ENE, and actually you wouldn't put ENE, you would just put EN, if there was something that has a higher priority on the main chain. So it has a double bond and something else in the higher priority at the end of it. So this is accounting for your ENE. Okay. Let's see this guy. Only thing I'm gonna get you on this one. I'll make it look pretty. And there's spaces between these guys. And let's see, 1, 2, 3, 4, 5. A bundle. And here, let's see, 1, 2, 3. Yeah, you're good. You're good. And let's see. That's 1, 2, 3, 4, 5. So 3. That's good. That's good. Who is doing G?
I don't know. I thought we were supposed to do it. I don't know.
Okay. Did somebody do it?
It's right there.
Am I blind?
Like right here.
Oh, I see it
Oh,
now.
it disappeared.
Yeah.
There you go. Okay, but here, you're going to have it. Oh, I see it now. I see the whole thing. Yeah. Good job.
It's tripping, right? I can't even see it.
Yeah, it's crazy, huh?
And it's in.
Okay, so that's 1, 2, 3, 4, 5, 6. Yep, looks good. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that looks good. And 1, 2, 3. 1, 2, 3, 4. So it's butyl, propyl, ether. Okay, you guys got this.
I have a
Good
question
job.
for 8.
Yes.
Would it be a 5 non-unknown?
Yes, you're correct. Good eye. Me. All right, hold on.
I'm kind of confused on I.
On I? I is like the easiest one, right? So you have the oxygen. Oxygen acts in the middle, right?
I think it's hard.
Well, just look at it.
Yeah.
Just let me talk to you, and then maybe you can change your mind. But oxygen right there is in the middle. So then you count the first carbon. 1, 2, 3. What is the 3 carbon?
Mm-hmm.
What is the 3 carbon? Propyl. Okay.
Propyl, yeah.
Okay, so that's where we get that from.
Oh wait,
And then-
in alphabetical order. Yeah.
Yep. On the other side, 1, 2, 3, 4. Butyl.
How come G is not in alphabetical order? Because it's one of them's the strand and the other one's the thing, or?
Yeah, so it's not completely in alphabetical order, but these guys are in alphabetical order.
No, G.
G. So it'd
Oh,
be
G?
bromo 3,4-dimethylhexane.
Okay, this one here, technically, it should be, the bromo should be first.
Okay.
So I just get excited that you guys have all of the structures.
Like we understood it and we got it, but we had to be looking at our notes. Like there's no way we could have memorized that. Like
Well, when did you first introduce to it? When was the first time you used it?
today.
Wow, right? So today you're still looking at your notes to do it. That's okay. But long as you keep doing it, like what you guys should do, if it were me, I would hook up with some of the people that I had in my room or something like that to be like, hey, give me your number so we can sit there and I'll send you one during the day. And then you tell me the answer. You know, so then that way you guys are just keep going, right? And so you get used to it. The more you use it, the better it is. Tell me this. How many of you guys came out of your mama walking? Anybody?
Nope. Yeah. I
How
wish.
many of you guys came out of your mama running? Anybody?
No.
How many of you guys came out of your mama driving? Anybody? Right.
Jackson
Didn't you have to learn all those things? And how did you learn it? Did you go the first day and like, oh, I can drive, or oh, I can walk, or oh,
No.
I can run?